Hi, boys and girls. We have finished Module 3. So as a way to practice, because this year we have finished up and we're going to have a few days off before we have the end of module assessment. So we wanted you to have the opportunity to preview and practice. So let's begin. The first question asks you, what is the greatest multiple of 7 that is less than 60? So obviously you have to write down the multiples of 7 and make sure you do them properly. And then go down the greatest one that is less than 60. Well, we have 63. So the greatest that is less than 60 is 56. So we would circle that. Now, this is to identify each number as prime or composite and list its factors. So if we have 3, we know that the only way to multiply to make 3 is 1 times 3. And since there are only 2 factors, that makes it prime. For 6, 1 times 6 and 2 times 3. So 1, 2, 3, 6 are the factors, which makes it composite. 15. 1 times 15 is 15, and 3 times 5 is 15. So 1, 3, 5, 15, which makes it composite. 24. 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, and 4 times 6 is 24. Whenever we're trying to do factors, we go in order. 1, 2, 3, 4. Could it be 5? We go in order from 1 moving upward to check to make sure that we have every single factor. That makes 24 composite. 29. Well, we can only multiply 1 times itself to make 29, which makes it prime. Okay. Any place value strategy to divide. So anything at all. So even if you know 9 times 4 is 36, you could do 400. But I did long division. You could use place value discs. You can use the distributive model and a number bond. You can use an area model. So any strategy that you would like, you can use. So 36 divided by 9 is 4. If you subtract, that's 0. Bring down the 0. That's 0. That's 0. That's 0. That's 0. So it's 400. Now this one's a little trickier. 96 pencils come in a box. If 4 teachers share 3 boxes equally, so there are 3 boxes of 96, how many pencils does each teacher receive? Well, first we have to know how many pencils there are. There are 3 boxes, and each box has 96. So that is 96 times 3. Because we have 3 boxes of 96. And if we multiply, 3 times 6 is 18. So 9 times 3 is 27, and 1 is 28. So altogether, there are 288 pencils. 4 teachers are going to share those 288 pencils. 28 divided by 4 is 7, because 7 times 4 is 28. 28 minus 28 is 0. Bring down the 8. 8 divided by 4 is 2. 2 times 4 is 8. 8 minus 8 is 0. So each teacher will receive 72 pencils. You need to have your statement. Now, they want you to solve this division with place value discs. So hundreds, tens, ones, you have to draw your place value. 400, 4, 22, 7. So if we divide it into 3 sections, 1, 2, 3, with 1 left over, we need to decompose that into 10 tens, which will give us 12 tens. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And none left over. So now we have 7. 1, 2, 3, 4, 5, 6, and we have 1 left over. So that gives us 100, 4 tens, 2 ones, with 1 remaining. So now we have to solve it numerically. 427 divided by 3. 4 divided by 3 is 1. 1 times 3 is 3. 4 subtract 3 is 1. Bring down the tens, please. 12 tens. 12 tens. 12 divided by 3 is 4. 4 times 3 is 12. 12 minus 12 is 0, because we had no 0 leftovers. Then we have 7. We do the ones. 7 divided by 3 is 2. 2 times 3 is 6. 2, 4, 6, with 1 remaining. So we have 142 with 1 remaining. So it matches. Any place value strategy to multiply or divide. For division, you can use long division, the standard algorithm. You can use place value discs. You can use the distributive model. So here we go. 5,316 divided by 3. 5 divided by 3 is 1. 1 times 3 is 3. 5 minus 3 is 2. Bring down the hundreds, please. 23 hundreds. Divided by 3 is 7. 7 times 3 is 21. 23 minus 21 is 2. Bring down the ones, please. 26 ones. Wait a second. Should I have brought down the 1? Wait a minute. I brought down the 3. Oh, this should be a 1, shouldn't it? 1, which would give us a 7. And this would be 21, which would give us, oops, 0, bring down the 6. And how many 3s? There won't be a remainder. Look at this. How many 3s are in 6? 2. 2 times 3 is 6. So, let's make this a little bigger. Goodness gracious. I didn't do this correctly. 6. And 6 minus 6 is 0. Look at that. No remainder. I made an error. Good thing I double checked it. So it is 1,772. Now we have 3,809 divided by 5. Hopefully I did this one correctly. 38 divided by 5 is 7. 7 times 5 is 35. 8 minus 5 is 3. Bring down the tens, please. 30. 6 times 5 is 30. 30 minus 30 is 0. Bring down the ones, which is 9. 9 divided by 5 is 1. 1 times 5 is 5. 9 minus 5 is 4. Remainder 4. And now we're going to multiply. So we can use our partial products. You can use 2 partial products or 4 partial products, whatever is easier for you, or the associative property, if that's easier for you, whatever works. So 56 times 29. That's 9 times 56 and 20 times 56. 9 times 56 is 504. 2 times 56 is 112, so it's 1,120. And if we add those together, we get 1,524. 43 times 17 is 7 times 43, 10 times 43. 7 times 43, 10 times 43. 7 times 43 is 301, and 10 times 43 is 430. If we add those together, we get 731. Now we're into word problems. As we know with everyday math, Eureka Math, the further along you get, the more difficult the problems get. So they don't expect, they would hope that you would get at least to the standard algorithm of multiplication and division. They hope that you get to these problems. This page, 5A and B and C and D are the extensions. They're applying what you've learned. So if you don't get to these problems, it's fine. These are kind of like extra credit to see how you do. So let's see how you do. So a new grocery store is opening next week. The store's rectangular floor is 42 meters and long and 39 meters wide. So 42 times 39. How many square meters of flooring do they need? So we know that we have to do 42 times 39. So 2 times 39, 40 times 39. Same thing here. 2 times 39, 40 times 39. 2 times 39 is 78. 4 times 39 is 156, so 1,560. If we add those together, we get 1,638. They want us to estimate to assess the reasonableness. So I would estimate 39 to 40 and 42 to 40, because 40 times 40 is 1,600. I would say that's pretty reasonable. Our estimate and our actual are very close. So the grocery store will need 1,638 square meters of flooring. This one's a little trickier. The store ordered small posters and large posters to promote their opening because they're having a grand opening. 12 times as many small posters were ordered as large. And if there were 48 large, how many more small posters were ordered than large? So that's 12 times 48. So that's 2 times 48, 10 times 48. 2 times 48 is 96. 10 times 48 we know is 480. So there were 576 small posters. However, that's not what they asked. How many more small posters than large posters? So we need to do small minus large. And when we do the small posters minus the large posters, it's 528. So there were 528 more small posters than large posters. So that's why these are a little more of an extension. This is an extension because you need to do an estimate for reasonableness. And this is an extension because you're multiplying, but then you have to subtract. So it's a 2-step problem. So now uniforms. People who work there need uniforms. And they're sold in packages of 8. The store's 127 employees will be given 3 uniforms. How many packages will they need to order? So first we need to know how many uniforms do we need? Well, there are 127 employees and they're each getting 3. So that's 3 times 127. So how many uniforms will they need? 3 times 7 is 21. 3 times 2 is 6 plus 2 is 8, and 3 times 1 is 8. So they're going to need 381 uniforms, and they're sold in packages of 8. So how many packages will we need? 381 divided by those 8. 38 divided by 8 is 4. 4 times 8 is 32, which leaves us with 6. Bring down the 1. We have 61 ones. 8 times 7 is 56. 61 minus 56 is 5, so they'll have 5 remaining. They still need to order 47. They still need to order 47 packages of uniforms to have enough. So again, this is an extension because you need to multiply first and then divide. And finally, there are 3 numbers for the combination of the store's safe. The first number is 17. We know that, okay? The other 2 numbers can be multiplied together to give a product of 28, which means it's the multiples of 28. What are the possibilities for the other 2 numbers? Write your answers as multiplication equations, and then write all of the possible combinations to the safe. So the multiples of 28, 1 times 28 is 28, 2 times 14 is 28, and 4 times 7 is 28. So these are our possible combinations. We know it has to start with 17. It could be 17, 1, 28, or 17, 28, 1. 17, 2, 14, or 17, 14, 2. 17, 4, 7, or 17, 7, 4. And we're just kind of doing the turnaround facts. We're just doing the multiples going forward and going back. Okay? So hopefully this practice has helped you, and you'll be ready to take the test and do the best you can. Because that's all we want you to do is try to kind of reflect and use all the strategies that you can to be successful. We just want you to do the best you can. So like for this problem, you could write the multiples of 8. That would help you. You need to do the work on the sides to do this problem. For these, you need to do some work, just like I did. For these, you might want to do the multiples of 3 here and the multiples of 5 just to help you. And the same for this, the multiples of 3. The more you write the multiples, the more fluent you'll become. You can write the multiples of 9 here, the multiples of 4 here. And just take your time here to make sure that you get all of the factors. And you have the multiples of 7, so just do this carefully as well to make sure that your numbers are correct for your 7s. Okay? And just do the best you can. That's all we want, is that you take pride in your work and you persevere and you use all the strategies that you have at your fingertips and do the best you can. And we will see you tomorrow in school. So have a wonderful evening, and we'll see you bright and early tomorrow. Bye-bye.